So hello everyone. So in this class, we are going to discuss about the calculation of a normal stress, or otherwise it is called as a principal stress in a cantilever beam. So here it is a simple problem. A cantilever of span. So span which means length. The cantilever beam is there. A cantilever of span is 250 mm and 50 mm diameter. So carries a vertical downward load of 3 kilonewton at free end along with a torque of 1000 newton meter and an axial pull of 15 kilonewton. So we have to find the maximum normal stress, that is called as principal stress, at top and bottom face of the fixed end. So just look at this diagram. So this is a cantilever beam. So cantilever beam, which means one end of the beam is fixed, another one is at the free. So here at the free end, so the load of 3 kilonewton is acting. Okay, so the total length, that is the total span of this cantilever is 250 mm. So one end of the cantilever beam is fixed, another one is at the free end. So in that free end, the first downward load is 3 kilonewton is acting on it. And the second one is there is an axial load. So the axial load which is taking on a outwards direction. So this is called as an axial pull. So this pulling force which is acting on the free end. So this is called as axial pull of 15 kilonewton. So apart from this downward load and an axial pull, so there is an another load that is called as a torque, called as twisting moment, which is acting on it. So the total torque acting on this shaft is 1000 Newton meter. So here what will happen when we are considering these three loads? Based on considering these three loads, we have to calculate the maximum normal stress, or otherwise it is called as a principal stress at top and bottom face of the fixed end. So here it is the fixed end. So in this side, in this fixed end, so this end is called as a top end and this end is called as a bottom end. So based on the three different loads, that is downward load and axial load and the twisting moment or torque, what is the stress will be acted at this point? So at top face of the fixed end and bottom face of the fixed end. So we have to calculate these things. Okay. So here, while calculating the principal stress at this point, what will happen? What we have to do is we have to consider all the three loads in an individual manner. Okay. So first, the given is axial load is given, that is 15 kilonewton. So 15 we have to convert it into Newton. So that is 15 into 10 power 3 Newton. So here the load is acting on a downwards direction. So that will be considered as bending load. So bending load is 3 kilonewton, that is 3 Newton, that is 3 into 10 power 3 Newton. And the torque that we are taken as m into t. Okay, that is twisting moment, that is 1000 Newton meter. We are converting into Newton into mm, that is 1 into 10 power 6 Newton mm. And diameter of the shaft is actually it is 50 mm. So here in the diagram it is wrongly mapped as 60 mm. So take it as 50 mm, and the length is 250 mm. Okay, so here we have to calculate the normal stress. So first we have to consider the axial load. Okay, so before that, calculate the area of the beam, that is area of the total shaft. So that will be considered as it is a circular shaft, circular cross section. So it will be considered as pi by 4 d square. So diameter is 50. So pi by 4 into 50 square. So the total area of the cantilever beam or shaft, it is 1962.5 mm square. So based on the early discussion, so three loads are acting. So first we are considering the axial load. That is, so if your load is acting on your shaft or a beam, what will happen? The stress will be induced. So here axial stress, that is the axial load is acting on the shaft or cantilever. So it will be considered as a tensile stress. Okay, due to the axial load. So sigma considered as a stress. So here it is a load acting on x direction or x axis. So here it is axial load. So that is sigma xa is equal to load by area. So load here axial load by area. So the total value is load is 15 into 10 power 3 divided by the area what we have calculated. It is 1962.5 mm square. So the total axial load and its stress is we have computed as